Hello everyone, thank you very much for joining this live event. This is lesson number 10 already from the Spring Security Fundamentals stream, and we discuss about cross-origin resource sharing, also known as CORS. So in the previous lesson we have discussed about CSRF, and now we are continuing our deal with one of the other important filters in Spring Security. That's the CORS one. If you are watching the event live, don't forget that we have a live chat there, so I always have an eye on the live chat, and you can ask me questions directly in the live chat. If you are watching the event recorded afterwards, you can still ask questions in the comment section, or you can find me on LinkedIn or Twitter, and you can add me there, and you can ask me questions, and I can answer them either in a separate video or in the next lesson, depending on your question. But the idea is you can get in touch with me. So with that being said, let's continue with our today's lesson. I have to create another project. I'm still on the project 9 here, so the previous one. So let's create together another project we'll use today for our demonstration, and that of course I will use to teach you how CORS is working and what's the deal with this filter in the Spring Security filter chain. So that being said, let's create a new project, and yeah, we can choose latest and greatest, Spring Initializer, and then I need to name it C10 because this is our 10th lesson. And then we'll need to add our dependencies. For today we'll be adding the Spring Web dependency, the security dependency, of course, and I might use TimeLeaf because I would like to create some pages. I'm not sure if I will use it, but let's add it there in case I will need some tags. So I think this is it, and that should be enough for us for our today's demonstration. So let's simply create a project, and I will close the previous one because I don't need it anymore, and this will get indexed soon, and then we can use it. But meanwhile, let's discuss a bit what CORS is, and I have prepared a couple of diagrams here for you. So the idea of CORS, which is named again cross-origin resource sharing, it means that you have multiple origins. So it actually refers to what happens to a web application when it consumes multiple origins. And an origin is basically, in this case, referred as its domain. And you know, it simply happens a lot of times that we use multiple origins nowadays, especially with applications using a kind of a front end and the back end. Sometimes you load content from a specific origin like example.com, but then you have another origin that implements your REST APIs. That's, for example, api.example.com. And I'm pretty sure you might have seen this, or if you didn't see, it might really happen in real world scenarios to see this. And there are specific different kind of situations where you have multiple origins. This is only one of them. It can simply be that you are loading some part of your content from a separate origin. It can be that, as presented in my example here, you have an iframe that's loading some part of our web page from a specific different origin than your application is. And anytime you get with using multiple origins in the same web application, you deal with this policy that is called cross-origin resource sharing. So this policy, the cross-origin resource sharing, allow you to specify when multiple origins are allowed and which are actually the origins your application allows to get content from. So in my case here, you have as an example, I have an iframe here, and it's loaded inside a web page that has been accessed through the origin example.com. So I got the content of the whole page from example.com, and then inside this content I have an iframe that's loading some content from example.org, which is of course a different origin. So being that here I have a different origin now, I will not be allowed to get the content of this origin if I don't specify that I allow this origin. by default the content from the response from the origin that's not allowed is not accepted, and then you will generally get an exception in an exception error message, rather say, in your JavaScript console in your browser, mainly because in general you will face a lot of times these issues when you deal with calling for example specific endpoints via REST functionality. So this is in general what happens. So when you have multiple origins, one of them is the main one, and then whichever other origins need to be loaded, they have to specify that they allow a specific origin to load content shared by them, and if they don't allow, and by default they don't allow, then the content won't be displayed, it won't be accepted by the browser, it can't be used by your client application, and in general you see this as an error message. So just down below I have another example here, where during today's lesson I will refer to some headers, and one of them, mainly the most representative of them, at least to allow you understand, because you don't need to know these headers by heart, but you will read them, you will face them when dealing with CORS. If you read specific documentations like the RFC for the CORS and so on. And the most maybe representative header is the access control allow origin header. This access control allow origin header specifies which are the origins that are accepted. So in my case, if previously in the first diagram the content from example org wasn't accepted, now the example org actually specifies in the response that it's accepted, that example.com loads it, and in this case you will be able to see your content. So let's see, Angular application, we are using 4200. Is it necessary to add cross origin? Yes, I was actually going to get to that. Yeah, I'm not developing today an Angular application, but one of the most encountered situation I have seen in development is that developers, today it's very, very common to have an Angular or React or Vue front end, and then you have a back end that you consume. And what happens is that, for example, when you use Angular, you develop your application and you are very used to using ngserve for that. So you simply use ngserve, and when you do that, assuming you use defaults, that ngserve will actually run you a server that's providing the content of your Angular application on port 4200 by default. Okay, so when you do that, assuming you are using ngserve, you use ngserve in your console, the ng server starts, and you have exposed your application on localhost 4200. Then you have a Spring Boot application, probably let's assume you're running on the default 8080, but anyway it doesn't really matter because it will be a different port, assuming that both of them you are developing locally, so they are on the local host, so they have to have different ports. So you now have one application running on localhost 4200 and one application running on localhost 8080. And guess what's happening? Because you now have two different ports. Even two different ports mean two different origins. So that's why basically in your case, and again I was going to that in the example, I'm just starting now to warn you with what is, but that's a very, very good example of what happens in a development environment. You have now two applications running on two different ports, 4200 and 8080, and the one in 4200 needs to access what's on 8080. So look our two origins. And then yes, one of the solutions, I will teach you today two solutions for that. One of them, the worst actually, is using at cross origin. The cross origin you will see is a static way to specify that you allow, in this case you allow the localhost 4200, which is the other application, in my case equivalent to example.com. So you place in your application here, instead of example.com you have localhost 4200, instead of example.org you have localhost 8080, and then by cross origin, as you will see in my examples today, in today's lesson, you specify, yes, I allow localhost 4200 to access my application. And that's why, yes, you need to add cross origin, and of course I will teach you another option as well besides cross origin when you deal with such situations. But that's a very good example of where you encounter cross origin. That's a good example where you encounter cross origin where you deal with the development of the application, but cross origin is something that you deal with also directly in production and in real world scenarios. So what I was teaching you here, I referred first to the real world scenarios where you, for example, use a specific JavaScript calling your APIs from a different origin, or you have an iframe that loads the details from a different origin, and so on and so forth. So you need to specify that origin has the ability, can call your endpoints, and if you don't do that, if you don't say here localhost 4200 is allowed, then the content won't be allowed. So that's something you need to know, and this is something else I will come back to it after our example. So let's now continue with our example. I have created at the beginning of our lesson this example, and it only has a couple of dependencies. Actually, it has 3 dependencies including the timelift. We want to prove how CSRF works, so for that I will need to create a controller, and then I will need to create some configuration. I will prove firstly I will prove how it works, like the restrictions, and then we will use the cross-origin resource sharing policies to relax this policy to make the restrictions more relaxed and allow multiple origins, and that's the plan for today, and I will show you how to do this with Spring Security. So let's create a separate package. We call it controller, and inside the controller we can create let's call it main controller. And inside the main controller, this being that I will create a web page as I have specified in the beginning, it will only be a controller. And in my case, I will have a main page, I have a get mapping, and then I do have to return main HTML here. This get mapping is basically to the root page. I can put it like this, but it's not mandatory, but for you to see is the root page. And here in the resources, of course, I'm using timelift, so I have to put it in the templates. I create an HTML file. I have to call it main, and here is basically where I will put a very small JavaScript code to call my an endpoint from my backend. So to spare some time, I have actually already written my code here, and I will simply put it because that's not what we are discussing. So I actually have to put it between a script and the slash script. And it's a very small and simple script that should allow us to prove what happens when we try to call some specific endpoint. So you see here what I have. I create an HTTP request and I call this URL, which is, let's for the moment call it on localhost, and localhost 8080, and then I need this endpoint test. So let's create an endpoint. This is very similar to actually just calling it through some Ajax or something. It would work the same. So we do here a test endpoint, and we make sure actually it was a post if I remember correctly. So it was a post call in my case. Okay, and it's not mandatory to be a post, it could have been a get, but I want to show you through this also some differences with what you have learned in the previous lesson, which is the CSRF. And here I do return only a test, and what I return from here I will put it in a div. So I said here when the event finishes, find the element with the ID output, and then the body of the response will be added to this. So I need to add an element like any kind of a paragraph or a div or something with this ID. So at the end, when the call ends, the body from this call will be assigned to the inner HTML of this. So hopefully this will be my page working. And now a complete lecture on microservices with Spring Security Yes, I will do that, but if you allow me first just to finish the entire stream, because I first try to take it lesson by lesson and make sure that everybody knows all the fundamentals. Otherwise, if I do a complete stream with microservices and people watching it don't know fundamentals, and from my experience as a consultant I have seen that pretty often, then not a lot of people will actually understand what happens there. And if I do this at the end, so after I finish my Spring Security stream and discuss OAuth, discuss OpenID Connect, discuss all the components, discuss what happens when you have a Keycloak or Okta, discuss what happens when you have a reactive application, then at the end I can discuss about the whole in a let's say a masterclass about this. But I want to make sure first I cover everything in detail. And to cover everything in detail, as you can see, I'm already at the 10th lesson here of 1 hour. So that's why I'm doing that. But yes, thank you very much for your suggestion. I will actually do that. I have it in my plan to do a separate specific one at the end when I discuss what happens and all the details and put them together in a microservices system as you suggest. Okay, so perfect. Going back now to our CORS implementation, so I need also to do some tricks here to make our example easier. Otherwise, we will have to work a lot more. And what I'm doing here, I will do my configuration class, and inside my configuration class, I will extend the web security configurer adapter, web security configurer adapter. And then I do override the method configure, and one of the things I'd like to show to do first is just disable the CSRF. So I would like to disable it. This is something we discussed in lesson 9. So generally you don't disable your CSRF, but for the moment, to allow you focus only on CORS, then I will disable CSRF, and moreover I will even disable, so let's say authorized requests, any request, permit all. So I would like to completely remove authorization, completely disable CSRF. We have now only the CORS filter enabled, and we focus only on the CORS filter for you to understand how this works. So that, because otherwise we would have to do plenty of other things like taking the CSRF token and everything we discussed in the previous lesson. And if we have to do also that, you won't be able to focus on what we discussed today, and you might get lost on the road, and of course we would consume also more than the time than we have allocated. So that's really important. So that's why I did this. But CORS and CSRF, they are together, they are working together. Generally you use them together, so that's for you to understand that only for this example I disable this just to make it easier, but in general you have them together in real applications. And if you still have questions about CSRF, you can review the lesson number 9. As I've said, that's where I have discussed in detail CSRF, and if you still have questions, then of course you can ask me in the comment section and I will answer them. So that being said, I'm curious now. I should be able to maybe already start my application here. So let's start the application. Let's see what happens if I try to reach from a browser. Do I have a browser here? Of course I have, because I'm live. So I need to have a browser. So that's, I create a new tab and I put it in front of you here. Localhost 8080 is the page. And yes, we have some. Oh, okay, sure, sorry for that, my fault. So I'm calling the endpoint as it would be a REST endpoint, but I actually use only controller here for this one. So that's why I should have actually added also the response body here, annotation separately for this one. And in general they would go into completely two different controllers, but in my case, to make the example simple, I will put them into the same controller. So yeah, if I don't add the response body annotation, then this will enter the standard Spring MVC flow, and instead of returning the body, Spring will try to find the physical view name and this physical view name, of course, it doesn't exist because I planned to only return the body here. So that's why I have added the response body annotation to instruct Spring that I only need to return directly the body, and I don't need it to look after a physical view name like a web page with that name. So that's what I was missing. So going back now to my web page here, and I loaded, you can see the test there, and I will go here and I will actually see the console because I will need it. So what I'm doing, I'm accessing from localhost 8080, and I'm accessing, you see here from the page, I'm calling still localhost 8080, so I'm on the same origin. So this is working because being on the same origin, it will always work unless you have some other, I don't know, fancy configurations, but in terms of CORS, you have the same origin, then it's no problem. But if I'm going here and I'm actually replacing that with 127001, then what I expect is that it doesn't work, and you can see how dramatically and instantaneously everything changed. And instead of seeing the body as I expected in my div, you will see here an error message. So difference between controller and REST controller. The difference between controller and REST controller is that when you use with Spring Boot controller here, Spring Boot will expect to you to return the physical view name, or at least to work on the Spring MVC. There are multiple possibilities. You can use the model MVU, you can use the model class. So in general, when you use controller, Spring Boot expects you to refer to a web page in the end, and then to Spring expects to find that web page, in my case main HTML, render it, and then provide it to the client through the response body. When you use REST controller, it's actually almost equivalent to controller, but it's an aggregation of two annotations. So you have controller plus response body equals REST controller. So that's the difference. When you say REST controller, is controller plus response body. So that's why here I have used this response body, because I want this endpoint to be as if I have used REST controller, but I want to keep this one only with controller. So for this one applies the Spring MVC flow. So Spring will look to find the main HTML page and render it, while in this case Spring knows it does not have to look for a page. But instead of looking for a page, it simply returns directly the response body as it is here, like text exclamation mark. If you go to the REST controller annotation itself, you will see precisely what I've told you. REST controller is actually a controller plus a response body. So in our case here, we use controller over the class, and for any method that is not specifically annotated with response body, it will try to find the page in the templates here, because I have also added timeleaf. If you also add the response body, then you will actually instruct Spring that if for that specific endpoint, it doesn't need to go and look for a page, and will automatically just add to the response what the method returns here. You might also find useful my complete explanation on Spring with REST on the same channel, where I have a complete Spring stream you can watch, and there I have explained a lot in details what controller, REST controller is, service repository component, and basically everything that is managing the context as well as managing endpoints. So that's on short what I can how I can let's say make an overview on controller and REST controller. But if you want to see it more in detail, I have some hours recorded there already on the same channel, and you can find them more in detail explained. But I hope you did understand here why I have used controller and the response body, and that REST controller is basically their combination. Yeah. And yeah, going back, what you have seen is that in my case, well, no longer the body is here, and no more than this, you will see that my functionality here trying to access the endpoint, the test endpoint, failed, and it says something like has been blocked by CORS. So it's something with CORS. Yes, of course, because we have two origins, so that's where CORS is coming into action. And it says you have no access control allow origin header present. And you now remember that I have shown you this header was the one we discussed here. Is the one that if present, it tells the client that a specific origin is allowed, but if it's not present, then you have to you have to either have the same origin, or if you have multiple origins like I have here, then of course the response will be blocked. Yeah, like in the first diagram here. So you don't see you see nothing because the response has been blocked because I didn't specify that I use multiple origins. So that's the problem here. It's a simulation in my case. 127.0.0.1 is basically localhost, but because it's different as a string, the browser interprets it as different origins. So that's how I trick a little bit. In my case, I do a trick and I use the same application where in one situation works because I have used precisely localhost, and then the used call here. Sorry, this is the one. The use call here corresponds with the origin, but then when I changed the origin, actually it didn't correspond anymore. So now localhost is not equal anymore with 127.0.0.1 in terms of strings. The browser sees them as different origins and blocks the response because I have no I didn't specify anyhow that I accept multiple origins, and by default it will completely block my response. Good. First thing before showing you how to add multiple origins is to make you aware that this doesn't mean necessarily that you don't call the method. So do you think actually I have called the method before getting the response, or wasn't at all this method called? To see that, let's add a system out here. Is the easiest way to see that is to basically add a system out here, and whatever you want to print in the console will prove us if the method was or wasn't called, and that's a really important aspect. And I will restart the application and I will recall this page that is displaying the error. Okay, so once the application is done, you can recall it. You see the same error. I have called it multiple times, and each time the set phase was actually printed in the console. And this is really important because it proves you that CORS doesn't disallow the call of the endpoint. It allows the endpoint to be called. It simply doesn't allow the response to be accessed back. But if you would have done here a mutating operation, and now that's why I have used post here basically from the beginning, because I wanted to like imagine this is actually a mutating operation. So if I would have used a mutating operation and I would have actually allowed the mutation to happen, the data to be changed, CORS doesn't protect me from this. CORS will protect the client from receiving a response when the origin is not accepted, but it won't not pose any interdiction on the client to call the endpoint. So that's why you basically can see that the method was called, even though in the browser I do see the exception, even though in the browser I don't see the result, and it might look like nothing happened, but the endpoint was actually called. And this is where the third diagram I prepared for you here comes into action, where this is Because in some situations, but only in some situations, the endpoint isn't called at all, but there are cases in which the endpoint is called, and that really depends on the browser if this happens or not. So this is the shortest. In reality it's a little bit larger, the diagram, but I have minimized it to only what I need to explain so that I make it more clear for you. When the request is done from the browser, so when the browser creates a request, then it takes a decision whether it needs to do a pre-flight request. The pre-flight request is just a test request. Usually the browser decides if they do or not a test request before, and that depends generally on some conditions that are specified by some RFC, but that's not an important detail for us now, so I will skip it. The idea is we have two options: either the request needs a pre-flight or it doesn't need a pre-flight. They don't have any other option. It's a yes or a no. So if it's a no, if there is a no, then the original request is sent as it is. So that's precisely what happens in our case here, because if I would have had a pre-flight request, then I would have seen that the method isn't called. But in my case, you have seen that the method was actually called. So because the browser decided it doesn't need a pre-flight request, it called the method. And then I have seen in the console the sad face appeared. And that's because, again, CORS doesn't pose any interdiction on the client to call the endpoint. It poses an interdiction on consuming the response. So, okay, the method was called, the response was delivered by the server, but it wasn't accepted by the browser. That's CORS. And you will also find situation, the option request. I'm not sure exactly what you mean with the option request. Probably you mean if the option request is the one that doesn't or does require a pre-flight request. There are multiple cases. There is not only to be a specific method. So the pre-flight request. Oh, the pre-flight is an option request. I think that's actually the state, because I don't understand if it's a question or not. So yes, the pre-flight request, it actually creates an option request, but it's not really important. So in this case, just imagine it's a test request. That's all it's important from this perspective, because it's not helpful to know the details if you don't, I don't know, for yourself will implement your own browser or something. So in this case, yeah, if it needs a pre-flight request, then if the pre-flight request doesn't succeed, then the real request isn't at all sent. If it doesn't send the pre-flight request at all, then it will send the request. So that's why you will see situations in which sometimes the method isn't called. So like in my case here, I can see it is, and I know that a pre-flight request wasn't done before. Or I have the situation in which the pre-flight request is done and then the method isn't called. But in any case, you have to take into consideration that this is at the browser's decision. So again, the most important thing that I wanted to state with that is the method might be called. The CORS is not like the CSRF, where the CSRF didn't allow you to call an endpoint in some specific situation, like in the case you didn't have a good token, a good CSRF token. The CORS might allow the browser to call the endpoint and only reject the response. So be very careful with mutating operations in this case. That's very, very important. That's an important thing, and an important confusion I've seen sometimes through developers who tend to understand CORS and CSRF as being very similar or something very similar, but they aren't. They totally aren't. They do totally different things, and they act differently, and you have to be very careful with these details and the way it works. Cool. Now let's try to make it work. So one of the options one of the things we might use to make this work is to use the cross origin annotation, as somebody specified in the live chat above. So indeed, the cross origin annotation allows us to specify that we accept some origins. We can specify a star, never do that in a real world scenario. Yeah, that means all origins. Or you can specify, yeah, I only need HTTP or HTTPS something example.com. Okay, so in general you will need, I will go back to this after I show you the example. You will need to specify precisely which are all your origins. But let's discuss now this first option. You specify the origins, they might be provided as the value. If you go in the definition of the origin of the cross origin annotation, you will see actually that you can use the value, and it has also an alias, the origins here. So any of this you would use is the same thing, is the enumeration of the origins that are allowed. You want to allow those origins and you enumerate them. If you use a star, then you allow all the possible origins. You can see in the top of the definition of our annotation that there were at some point some constants here, default origins that contained the star, and it was made deprecated. Basically this was actually the default, and at some point in the history of the CORS annotation, it was basically the default for this. Instead of nothing, as you can see now. So that's why, depending if you are using a very old version of Spring Security, you might see that you can use the cross origin without anything and it will work. Now I do have to specify it, and the reason for why the default using a star was made deprecated is because it represents all origins and is not recommended. You usually are advised to, in a real world scenario, to enumerate precisely the origins like this with a comma separated, or as in this case of the cross origin, it can be either comma separated or even as an array as specified here, and it will work. I will keep the star here. I will keep the star for our example because I will anyway comment it out soon. And I will restart the application to see if this solves my problem. And basically you will be able even to see the header in the response. Yes, so I have restarted it, and I'm going here and I'm again refreshing. So the page that was previously not working, now it works. So I'm able from 127.0.0.1 now to call localhost, and the reason for that is the cross origin, the allowed origins that I have placed on my response. If I go to network here, actually you can select the page and we can see the header appeared indeed in the response. So because of this access control allow origin header that contains my origin, well, again, star means all the origins, but it needs only to contain my origin. If I have this, then it's enough for me to for the browser to accept this origin. So that's why I see now it's basically working. So this is what I've changed. Cool. So I've managed. I made it work. Okay. What's bad actually with the cross origin? Because I have told you I will comment it out. I will show you another option that is rather more practical, more usable in real world scenarios. And why is that? Where the cross origin has the problem of being only an annotation, you can place it directly on the endpoint or you can place it on the class, and that way you specify the origins that are accepted. But what happens is that in a real world scenario, you generally need to be able to configure the origins, because guess what? Usually you have multiple environments on which you deploy the same application. So it's not simply localhost and that's it and it's working. It's not either a single domain. In most of the situation, you have multiple environments in which you deploy the application. Imagine a real application where we have the production, but we also have 3 environments for test, and we have a QA environment, and you have a system integration test environment, and you have so on and so forth. So you have plenty of environments. So that's why we have Maven profiles, that's why we have Spring Boot profiles, that's why we need to be able to specify different properties, and the cross origins are different properties because they might be different depending on the environment you are using. And yes, you could of course use the cross-origin annotation and put them all of the test and production environments, but that's not desirable also. So you basically really want, when you deploy your application, to have only the configuration that it really needs. So that's why cross-origin is a cool annotation for proof of concepts. For examples, for tutorials, you will see cross-origin works pretty well. You can use it just in the beginning when you told me earlier, yes, I have an Angular application, I run it with ng serve on 4200 and I have a Spring Boot, and then of course it doesn't work. And before going to add all my origins, then to make it fast in the first sprints, I use the cross origin, but then you have to remove it and you have to make your application configurable, because if you don't make it configurable, then it would be much more difficult to deploy it on different environments, and of course it might even impose vulnerabilities, and you don't want that, because that's all about applying security. So instead of using cross origin, you would prefer to go to the configuration here and use the HTTP CORS configuration. So you can use the CORS with the customizer here. I've shown you that most of these methods you call from HTTP here can be used with a customizer. We actually used one of them even in the previous lesson. In lesson number 9, you have seen how to use a customizer on the CSRF. So that you can customize the way you manage your tokens. If you remember, the same thing you can actually do here, the same thing with CORS, where you use a customizer to customize the origins. So you can do something like this. This is my customizer. Again, customizer is an interface with only one abstract method, so that's why I'm basically able here to use it as a lambda. But remember, also an advice from my experience, don't usually in a real code, don't put everything, all the configuration all at once. So in this course we'll probably like to take it out in a separate class afterwards to make your code cleaner. So don't create a very huge code with all the possible configurations, otherwise somebody looking for a specific configuration would find it very difficult to see it. Will find it very difficult, and will understand much more difficult your application, so we can say that the application becomes less maintainable. So this customizer is where you can now configure the CORS configuration source, and the CORS configuration source is also an interface. So that's why I say CORS configuration source. Let's call it like this, and then you can actually use a lambda expression the same as I've done like here, and you just set it here. So that's basically, and the reason for why I'm able to do that is because if you would go into the CORS configuration source, you will see this is an interface with only one method, and the method receives the HTTP request and returns the CORS configuration. And this is the CORS configuration we would like to configure, and the reason for why it receives an HTTP request is to allow us the opportunity to actually make this CORS configuration customizable per request, which is really important because it allows you the most possible degree of flexibility for your real world scenarios, because in real world scenarios you find cases in which you would like for specific requests to specify different CORS configuration rules. So that's why it was designed this way. So this is the request, that's why I named it R. I won't use the request now, but you could use it again if you implement a more complex logic for your CORS configuration. But I need a CORS configuration, so I need to create such an object of type CORS configuration, CORS configuration, new CORS configuration, and then return it. And when I return it, there is where you will be able to set the allowed origins. One thing, however, you should make sure you need to set the allowed origins, but you need to also set the allowed methods. What I didn't tell you in the previous example is that it's not only about origins. You can actually be a lot more detailed into your CORS configuration, and you can specify not only the origins themselves, but you can specify which methods apply, which methods are allowed. And I talk here about the HTTP methods: get, post, options, put, delete, trace, and so on. You can even specify which are the headers accepted in the response, and if some specific headers are not accepted, then they will be automatically filtered out. In the case of the CORS configuration of the cross origin, annotation, when you use that cross origin annotation to define your cross configuration, that's done for POCs and to put fast in place some code to work. That's why you only need to specify the methods, and you can even just use the methods, use a start there, and that's all, so on. When you use the CORS configuration, you need to set both the origins and the methods, because none of them is specified. So if you don't specify them, it will basically not work. So that's why here I will not only say that I want to allow all the origins, or again, in general, you would specify your own origins depending on your application. And of course, this string here will not be statically in code. You can load it from the properties, which properties can then be loaded from the environment variables. And that is what makes this code different, this configuration different, is that you can make it based on your environment. Of course, you then have to use some variables here, the get value annotation. You inject the value and you use it from your properties, and then when you deploy your application in an environment, you can specify the properties from environment variables, and you create a customizable environment. So that's why we use it like this. So set allowed origin, and of course we need to set allowed methods as well, and then we need to create the list of methods we use. So in my case, I only use the get and the post, so I can only enumerate the get and the post here. And that's it. That's the second way you configure it. But again, the difference is that here you can take this from the properties file, because you can easily inject them here with that value, and you can specify them in your properties. You can have properties on profiles in Spring Boot, again, so on and so forth. I discussed this in details also in the Spring Framework Fundamental stream, so you can see there more in details. If you don't know what I mean here, then it might be a good chance for you to review the Spring Fundamental stream where I discuss this. And with this being configured this way, basically if I restart now, I should see the same thing. I will see the application working, because I did the CORS configuration. I relaxed the rules by allowing all the origins, and for these methods, these HTTP methods, and I can probably even see them in the response. Okay, it's working the same. And then you select it here, and you see that the header is indeed here again. Okay, I would have expected to see the methods as well. I'm not sure why they're not present here, but anyways, this is the configuration. So you see it now basically working precisely as we expected, and that's it. Perfect. So this is how you configure CORS. This is how CORS is working in general. And I probably didn't skip any important details. You can discuss about all the methods here and all the configurations, but I guess now that you would be able to simply use them and that you understand them the way they are. And it's not such a big deal with this course, but you have to at least remember what it is and understand it in terms of how and what it actually protects, and to understand that basically the protected resource here, protected, let's call it actor here, is the client, not the server. And that's why in my first example here, I have actually returned only I have crossed over only the response here, because this is what's not happening. So I can see that you are using Codota. What is your opinion about that plugin? Actually, I did start using Codota a couple of weeks ago, and the plugin is nice. However, being that I used it only for very small applications like my examples here for courses, I didn't observe a lot of enhancement. I will try to use it also for my work, but I have to make sure for the beginning that you know, when you use a cloud plugin or something that can manipulate your data, and you work in an organization where your code is private and it's really important, nobody not allowed explicitly to see it, then I'm a little bit concerning about the security of CORS. So I'm not really sure, and I think in case of what I'm doing, I might need actually the approval from my organization to allow me using such a service as CORS. It looks nice in general, it's a nice AI. I'm again probably at least a little bit enhancing the way you work, but you still need to know what you are doing, so it's just a little bit probably more smart than a normal autocomplete of the IntelliJ. But again, the real reason I didn't use it in practice for now is because generally when you deal with some kind of applications, you are not necessarily allowed to use some cloud services, because you don't know what CORS, you know, it's consuming your code, it's learning from your code, and you are allowing CORS to actually access your code. So yeah, it may be. Could update too much. Yeah, it requires, yeah, exactly. So it requires access to your code because it's an AI, it's a machine learning that's learning from the way you're writing the code. So the problem is, it's a question of security there. Do you or do you not allow such a plugin to read your code? Yeah, basically that's it. That's mostly my opinion, but I didn't have that much experience with CORS. I've just started to try it, and being that again I tried with very small projects and only my examples, it's not necessarily something that I can come with a really heavy conclusion on CORS. And I have another question here. If this is also applicable for reactive, yes, the answer is this is also applicable for reactive, because reactive applications, they are still web applications, and in the end is of course different. The philosophy of the philosophy of the application is different. You have imperative applications and we have reactive applications. And to make a very short intro to what this is, when you have an imperative application, you get a bunch of data, and your backend, let's say, consumes the bunch of data, and then the client has to wait for the server to consume the bunch of data in order to get a response. While in the reactive applications, you don't need to get a whole bunch of data. You can have subsets of the data sent to the server, and the server there will consume the bunches, the segments of data instead of consuming the whole bunch, and then the client doesn't necessarily need to wait for the whole bunch of data to be processed. They can receive it in, let's say, in time with the processing. And we have the reactive streams as a specification, and probably the reactor implementation is the most used and the de facto used usually with Spring applications for reactive streams. In the end, they are still web applications. So in terms of CORS and CSRF, they do have to apply the same rules. The way they are working behind is that in case of reactive, you don't have any more one thread per request, the way it happens in the imperative applications, in the imperative style. And because of that, the management of the security context and the management of in general, the way the request and the response are processed are different. But Spring Security helps us with a lot of nice implementations that apply to the reactive applications, and things like applying authorization rules and the security context and all the other things we have discussed and we will continue to discuss in this stream, they do apply for the reactive applications as well. And we will even have a separate lesson in the future where we'll discuss only the reactive application, and I will show you how to do configurations for reactive applications with Spring Security, because you don't use the same classes and the same implementations. We will have to change a little bit the way we configure the endpoint configuration, or the global method security is different as well. The security context is not managed anymore by the security context holder. So there are some changes there, and I can even say that unfortunately the Spring Security for reactive is not yet mature enough. Because there are things that don't work, like the post-authorize, the pre-filter, and the post-filter annotation, which we'll discuss in the global method security lesson in one of the future lessons of this stream. They don't apply to reactive applications yet. It's an issue there open for, I think, a couple of years or something. I hope I'm not mistaken, but it's not solved yet. So we might still see changes for the reactive applications in the future. Yes, that's a lot to discuss. So it's another epic, we can say. That's why I planned to treat it in a separate lesson, or even in a couple of lessons. We might have to spend more than an hour to discuss about security for reactive applications. But Spring Security at least supports, I would say, the basics for reactive applications. Still has to improve. And I have again examples like the pre and post filtering, but you can apply at least the basics that you need, so to protect the basics of your applications. So we have Spring team is rewriting Spring Security. No, it's not rewriting Spring Security. It's rewriting the Spring Security authorization server, which is one of the components in Spring Security OAuth 2. So that's another story. It's an interesting one, because of course I will take it. I think just the next lesson we'll discuss about OAuth already. So we'll be discussing about what OAuth is, and you will learn that we have more actors that are dealing with OAuth 2 in a system, and we have the user, we have the client, we have the authorization server, and we have the resource server. These are the four main actors of an OAuth 2 system. What happened is that we had a new implementation for the resource server, and we had a new implementation to use the client login, but we didn't have a new implementation for the authorization server. And a few months ago, the team dealing with the OAuth 2, Spring Security OAuth 2, they decided, okay, we quit implementing anymore the authorization server, and we remained without an authorization server. And the great news is that because it was a bit of uncertainty, we still have applications there using their own custom authorization server. It's very true that you can use Keycloak, Okta, or some third-party solution, but you don't necessarily want to do that, not as a developer. But I myself had, for example, stakeholders that said, I don't want to use Keycloak, I don't want to use Okta, I don't want to use something else, I want my own implementation of authorization server. So what do you do if you don't have a library to allow you to do that? And that created a lot of uncertainty. I'm pretty sure I was not the only one in this situation, and I actually know a lot of projects. I happen to do a lot of consultancy on this domain, and a lot of people were uncertain of what's happening. So probably we will still use the deprecated solution until the new one is mature enough, and the Spring Security Authorization Server, hopefully it started now. I advise you to collaborate if you have the time and to develop at this component. I will do it myself, so I will participate myself in this collaboration and the development of this new authorization server. But we expect it will take some time. From my own experience, even if with a good team and a lot of people interested, it will not be a mature solution in less than a year. So maybe this next year we'll still use the old implementation of the authorization server, and then we will have to move along and use the new implementation once it becomes mature enough, and it's trusted by everyone. Like when a solution is related to security, it has to be trusted. Otherwise, if you know it still might have some vulnerabilities, you don't necessarily assume the risk to put it in a production environment. So I see many people waiting for this release to continue with book course. For this release, no. For example, I'm writing my own Spring Security book, and I'm not expecting for any kind of release. I will release it with what it is now, because that's what people need to know, and then I will simply create a second edition of my book when the things change. So because anyway, you will still, if you are still using now the old authorization server, you still have to use it, so you still need the documentation for that. It doesn't really matter if they deprecate it or not. You still need to use it because you have used it, so, and you don't have any alternative, you know. So yes, I myself, I'm writing a book on that, on Spring Security. You might know I do that with Manning Publications, and you can see the book there already, more than 2/3 finished. It's accessible in the early access program, and I'm not waiting for anything, so I still continue. I have only one chapter which is on the old implementation of the authorization server. I consider it very normal because that's what we have now. People need to know how is that working, and will be useful for them in the next at least 1 year. I expect at least 1 year, and then let's assume next year the authorization server will be in a new shape. Then I will just get out a second edition of the book, which will contain either both of the chapters. Either I will replace the one that contains the deprecated, depending on the usage in the community, of course. So that's my answer in regards to book and course. I wouldn't stop into writing a book or writing a course or writing articles about that, because it's only a very small piece of what Spring Security means. Cool. And that's it. We are done. Thank you very much. I hope you found this also useful, and I will share it as usual on my GitHub account. And we spent 1 hour to discuss CORS, and that's very important, as you have seen, part of Spring Security and of web applications in general. And I can't wait next time to already start with the OAuth 2 discussions. So stay tuned, because the next lesson we are starting the discussion on the OAuth 2, and the next series of lessons you will see how to implement a single sign-on login, client, resource server, and even an authorization server with what we have now in an OAuth 2 system with Spring Security. Until then, thank you so much for your attention, and stay safe and have a great time for learning.